Hello, hello, hello. Welcome back with Chapter 5 Graphs. Today we're discussing Lesson 4, Direct Variation. Now, direct variation is a relationship between two variables. Most commonly, it's going to be, X and Y. But they can be other letters, but they're two different variables linked by a constant. And this constant is just a number. It could be 4, it could be 2, it could be -1/2. It's linked by a number. So two variables linked by a constant, which is a number. So let's go over an example and see what this might look like. It says, suppose you make a peanut butter sandwich. Each sandwich is made with 2 slices of bread and 1 tablespoon of butter. No matter how many sandwiches you make, the ratio between peanut butter, which would be the x variable, so peanut butter is our x variable, and the bread is our y variable, remains constant. Okay, and if you see here, the x variable, that's the peanut butter here. And it's written in a table, a horizontal table. Usually when you have these tables, and you'll have some different examples like that, the x variable is on top, and the y variable is on the bottom part of the horizontal table. So, and then there's just a table of values. So this is in tablespoons, and this is in slices of bread. So if you use 1 tablespoon of peanut butter, that means you're going to have 2 slices of bread. Well, if you use 2 tablespoons of peanut butter, then you're going to have 4 slices of bread because it's representing 2 sandwiches. If you use 4 tablespoons of butter, then you'd use 8 slices of bread. And if you use 10 tablespoons of peanut butter, then you'd use 20 pieces of bread. Now, it's really, really important to know that this table, it's a table that represents x and y's and their relationship together, which also means that you can write these as ordered pairs. So you can write ordered pairs in a table format, or you can write the ordered pairs in just a list of ordered pairs, which we'll discuss in a little bit. Now, an equation is used to express the relationship between x and y. And this is the direct variation equation right here. This is it, okay? And here we have the relationship between the variables. There's our x and our y, which is what is a characteristic of direct variation. And then it's also our constant of variation. Our constant of variation is, our number is k. This is our constant, okay? And when we start getting into numbers, direct variation equations are going to look something like this. Y equals 3x, where there's the relationship between the x and the y, and then our constant is, we're using a k right now, which is a letter, but in the actual equation, the k is going to be a number, and that is our constant. So it might look something like that. Okay? In this equation, k is called the constant of variation. So k is called the constant of variation. It tells you how much x changes when y changes. Okay? And then the constant of variation, k, has its own formula. K equals y over x. And we're going to be using this formula quite a bit, so you're going to have to memorize it. Now, this formula is actually related to this formula. They're actually the same thing. They're just different forms. I'll show you real quick. If we start with the direct variation equation, y equals kx, and then we want to get k by itself. So is k by itself on this side of the equation? No, it is not. There's an x there. Well, how is the x related to k? Well, this is k times x. So we have to do the inverse operation of multiplication, which would be division, and we're going to divide by whatever this is, which is x. So I'm going to divide both sides of the equation by x, and then I end up with y over x equals k, which is the same thing as k equals y over x, which is the equation right there. So they're really just the same thing, the direct variation equation and this constant of variation equation. They're just kind of different forms. And you'll learn how to do this and solve for variables later when you get into algebra. But I just wanted to show you that these are connected. It's not like they're two totally different concepts. They're connected to each other. We're just rearranging the order. Here we have y by itself, and here we have used our algebra skills to get k by itself. Okay, so now we're going to go ahead and use our example here, and we're going to find out what the k is by using this formula right here. K equals y over x. So k equals y over x. So I'm going to take this first point right here where I'm going to determine the k. So I'm going to circle it, and let's go ahead and use it in purple. So k is going to equal, the y would be here, which is 2, over the x variable, which is 1. And 2 over 1 is just the same thing as 2. So the constant of variation is 2, okay? K equals 2. All right? Now I'm going to go ahead and determine what the constant of variation is here. So again, it's going to be, we're going to use the same formula, k equals y over x. So it's going to be k equals, the y variable is 4 over the x variable, which is 2. Now we're looking at these, this is a fraction, and we always want to reduce our fraction. Is there a number that goes into both of these, 4 and 2? Yes, 2 does. 2 goes into 4 2 times. 2 goes into 2 1 time. So we end up with 2 over 1, which is the same thing. 2 over 1, which is the same thing as 2. So k equals 2 again. It equals the same thing. Let's go ahead and try here with 4 and 8. We're going to find the constant of variation here. So we're going to go k equals y over x. So it's going to be 8 over 4. We need to reduce this. What goes into both of those? 4 does. 4 goes into 8 2 times, and 4 goes into 4 1 time, which is 2 over 1, which is equal to 2, which means k equals 2. And then lastly, let's go ahead and do this one right here. We're going to find the k, which is going to be our y over our x, so 20 over 10. And can we reduce this? Yes. What number goes into both of those? 10. 10 goes into 22 times. 10 goes into 10 one time. We end up with 2 over 1, which is 2, and our k equals 2 again. And if you notice, the k is constant. When we look at these, evaluate those two, the y and x, k is 2. When we evaluate these, 4 and 2, k is 2. When we evaluate 8 and 4, k is 2. When we evaluate 20 and 10, k is 2. K is constant every single time, okay? So that is a direct variation. When every time you look at these, the y and the x, you get the same k every time. Then you know that you're dealing with a direct variation. So if we're to find k, k is equal to 2. Boom, there you go. That's what k equals. Okay? Now what we can do is we can actually write an equation for this example here, because we know that the direct variation equation is y equals kx. So if for this data here, if it's y equals kx and k is equal to 2, then the equation would just be y equals 2x. That is the equation for this table right here. So you just substitute the k in for that number, and then you have the equation. So moving down here, the relationship between x and y can also be expressed in a graph. Okay? The line of the graph representing a direct variation always passes through 0, 0. So whenever you're dealing with direct variations, the line always has to pass through the origin. If you have something where you have a line that's not passing through the origin, then it is not like my pen here, right? The origin is here. If you had a line that was like up here or something and it doesn't pass through the origin, you can just look at it and say, hey, that's not a direct variation. Or if a line over here, you know, that would not be a direct variation. A direct variation always has to pass through the origin. So you can just look at something, and if you see that that line is not going directly through that origin, you know that it is not a direct variation. So now what we're going to do is we're going to express this in a graph. I'm going to zoom out a little bit so I can get this table and the graph in the same shot. Now it's really important that you understand, I mentioned this before, that this table is actually a different way of representing ordered pairs. And there's 4 ordered pairs here. The first ordered pair, and remember an ordered pair is just simply x and y. So whenever you have x and y, you have an ordered pair, right? So here, for right here, our x is 1 and our y is 2. So the ordered pair listed there would be, oh man, messed that up. It would be 1, 2. That would be the ordered pair right there. The next ordered pair would be here, and it would be 2, 4, because this is the x and that's the y. Okay? The third ordered pair would be 4, 8. That's represented there. And then our last ordered pair would be here. This is the x, this is the y. It would be 10, 20 right there. And so we can make a line of this table by just plotting these points. Okay, and we know how to do that. So the first point we're going to plot would be 1, 2. Okay, so right here I'm going to go over 1 and up 2, 1, 2. And so that point is represented right there. Then I'm going to go ahead and plot the next point, which would be 2, 4, right here. So I'm going to go over 1, 2, and up 4. 1, 2, 3, 4. Then that's right there. That's the point 2, 4. Okay, so this point was 1, 2. This point was 2, 4, which is right there in the table. The third point is 4, 8. So I'm going to go over 1, 2, 3, 4, up 8. 1, 2, 3, 4, 5, 6, 7, 8. Right there. 4, 8. And then the third one is 10 and up 20, and we can't get to that one. So this is 4, 8. Okay? And then after you plotted the points, you would just go ahead and connect the dots. And when you connect all of those ordered pairs, you see the graph of your direct variation, put lines on the end of it, and it goes through the origin 0, 0, so you know you did a great job, okay? Because direct variations always pass through the origin. So the problems that we're going to be discussing coming up is we're going to be looking at problems, looking at a table. We're going to be finding the k by going y over x and determining what k is. We're going to be determining if tables are a direct variation. So that means we have to look at each individual k, and they all have to be the same thing. If this was k equals 2, this was k equals 2, this was k equals 2, and then this was k equals 3, even if one of them is not k equals 2, it's not a direct variation, okay? We're going to be looking at some different equations. a y equals kx and seeing if they're in the format of y equals kx. And just by looking at the equation, we're going to be able to tell if it is a direct variation or not a direct variation. And then lastly, we're going to be looking at graphs and trying to tell from the graph what the direct, if it is a direct variation, and then what the constant of variation is from that graph. And I want to tell you that the constant of variation is actually the same thing as the slope, okay? So the constant of variation equals the slope. So if we want to determine, well, what is the constant of variation for this graph? Well, we just need to find the slope of this graph. And remember, the slope is equal to the rise over the run. Well, so let's start here from this point and go to this point, and let's figure out what the slope is. So we would go from here, we have to go up. So it's going to be positive. It would be positive 1, 2. So we'd know that our rise would be a positive 2 over the run would be to the right, which would mean it would be positive over 1. Positive 1, which is 2 over 1, which is the same thing as 2. So the slope equals 2, and the constant of variation, the k, that we found was equal to 2. That just proves that the k is equal to the slope, which is really cool because if we know that this equation is y equals 2x, we can tell from the equation that we know that this is the constant of variation, but we also know that the constant of variation is the same thing as the slope. So if the constant of variation is 2, then that means the slope of the line is also 2. So that's kind of cool how everything just kind of works together. So let's go ahead and look at some different problems. Okay, let's start with problem number 1. It says, what is the x variable in the table above? So in this table, we have x is represented by days and y is represented by hours. So the x variable is represented in days, whereas the y variable is represented in hours. Okay? And all these numbers are talking about days, and all these numbers are talking about hours. So for 1 day is 24 hours, 2 days is 48 hours, 3 days is 72 hours, and 4 days is 96 hours. Now what we need to do is write an equation that expresses the direct variation in the table. Okay, so we got to write an equation. Well, what is the equation for a direct variation? We know that the direct variation equation is y equals kx. So whenever you have y equals kx, really the only thing that you need to determine is what k is, because you're going to leave the x and the y as is, okay? So the only number you need to determine is the k. So let's go ahead and figure out what k is. We can do that. We know the equation for determining k is actually equal to k equals y over x. So let's just start here. K is equal to y over x, which would be 24 over 1. 24 over 1 is just 24. So that means that k is equal to 24, okay? And so let's go ahead and check the next one to make sure it's the same thing. K has to be constant. It has to be the same. So here, k is going to equal y over x. Y is 48, x is 2. So it's y over x, which is 48 over 2. We would need to put this, it doesn't look like 24 at the moment, so we have to see if we can simplify. They're both even numbers, so that means 2 goes into both of them. 2 goes into 48 24 times. 2 goes into 2 1 time. So it ends up being 24 over 1, which is the same thing as 24. So k equals 24. Ooh, it's the same so far, but we're not done. We have to check these two as well. So let's go ahead and check this next one. K is y over x, right? So it's going to be y over x. 72 over 3. 72 is our y. That is our x. Now we have to see if we can reduce this. Now, the only number that goes into 3 is 3. So I want to determine if 72 is divisible by 3. I can figure that out by adding 7 plus 2. 7 plus 2 is 9. Is 9 divisible by 3? Yes, it is. Since 9 is divisible by 3, that means that the whole number 72 is also divisible by 3. Now, I don't know how many times 72 is divisible, how many times 3 goes into it, so I'm just going to have to do the long division up here. So 72 divided by 3. 3 goes into 7 2 times. 2 times 3 would be 6. 7 take away 6 is 1. We drop down the 2. 3 goes into 12 4 times. 4 times 3 is actually 12, and then there's no remainder. So there we go. It goes in 24 times. So 3 goes into 72 24 times, and 3 goes into 3 1 time. So there we have it. There's another 24. That's great. K is equal to 24. Now we have to make sure that K is 24 for this one as well. So we have to do this last one here. Which would be K is equal to y over x, so it would be 96 over 4. Now, I don't know if 96 is divisible by 4, so I'm just going to go up here and figure it out. 96 divided by 4. Does 4 go into 9? Yes, it does, 2 times. 2 times 4 is 8. 9 take away 8 is 1. Then we drop down the 6. Does 4 go into 16? Yes, it does, 4 times. 4 times 4 is 16 with no remainder. So yeah, 4 goes into 96 24 times, and 4 goes into 4 1 time. So we're left with 24 over 1, which is the same thing as 24. And we have determined that K equals 24 is the constant of variation for each one of these ratios. So that means that K is equal to 24, and we can just substitute 24 in for K, and then we have our equation. Y equals 24x, okay? And that's it. We leave the x, we leave the y as variables, and the only thing we do is put in that number for K. And so that's our equation. Okay? Let's go on to problem number 3. It says, well, what is the constant of variation in the equation y equals 5x? Well, we know that the direct variation equation is y equals kx, and we know that the constant of variation is the k, and the k is right by the x, and this 5 is right by the x, and it's of the same format. So this k, the number in front of the x, is 5. So that means that k is equal to 5. So that's pretty easy in the equation, if it fits this same form, to identify what the constant of variation is. It's just the number that's right in front of x. Okay, let's look at number 4. Number 4 says, what is the constant of variation in the equation y equals x? Okay. So our direct variation is what, our just generic is y equals kx. All right. Now the y is the same, the x is the same. There is no number there. So we're trying to figure out what k is. But whenever you have a variable and there is no number, there's actually a number. The number in front of x is actually a 1. So y equals x is the same thing as y equals 1x. But nobody writes 1x because 1x is just the same thing as x, and so we just write y equals x. So y equals 1x, that means that the constant of variation would actually end up being 1. So k equals 1. All right. Now let's look at problem 5. Problem 5, it says, what is the constant of variation in the equation 2y equals 6x? Well, we need to know what the generic direct variation equation is, which is y equals kx. And is this equation in this form? What I notice about this y is it's very important. This y is by itself, besides the imaginary 1 that's right there, 1y. You need y to be by itself to determine what k is. So the question is, for this example, is y by itself? And the answer is no. Y is not by itself. There's a 2 right there. So what we have to do is we have to use our wonderful, magnificent algebra skills, and we have to get y by itself. Well, right now y isn't by itself. It is being multiplied by 2. So we have to do the inverse operation of multiplication, which would be division. We have to divide both sides by 2. 2 divided by 2 is 1. 1 times y is just y. 6 divided by 2 is 3x. Now we look at our generic y equals kx. K is here, the number in front of the x. And right here, the number in front of the x is 3, which means that our constant of variation is equal to 3. So sometimes if y is not by itself, you're going to have to solve y and get y by itself to figure out what the constant of variation is. Okay, let's move on to these next set of problems. The directions say, tell whether each equation represents a direct variation. If so, identify the constant of variation. Okay, so let's do 6 together. Direct variation, y equals kx. Well, we're trying to figure out, is that of this form? The y is the same, the equals is the same, the x is the same, and there's a number in front of x. So that means, yes, this is a direct variation. And k is equal to 4. Okay? What about number 7? Is number 7 a direct variation? Is it of the form y equals kx? Well, these both have a y. They both have an equal sign. Y is by itself, right? They both have an x, and they both have a number in front of x. Now, it just so happens it's a fraction, but that's okay. You can have fractions that are constant of variations. So for this one, yes, it's the same form, and the constant of variation is equal to 2/3. Let's look at number 8. Is number 8 of the form y equals kx? Well, they both have a y, they both have an equal sign, they both have an x, and they both have a number in front of the x. And it's a decimal, but that's totally okay. The constant of variation can be a decimal. So is this a direct variation? Yes, it is. K is equal to 6.3. Now let's go ahead and look at problem number 9. Okay, we want to know if this is a direct variation. Is it of the form y equals kx? Well, they both have a y. They both have a y. They both have an equal sign. So far that's the same. They both have an x. They both have a number in front of that x, right? But what's different? What's different is that the top equation has this +2 over here. Now that is not the same as the direct variation equation, which means it is not a direct variation. So anytime there is a number that's added or subtracted off to the side of this x, It's automatically, you can look at the equation and be, it's not a direct variation. Now there is a number. It's very important to understand that there is a number off to the side. The number off to the side is actually y equals kx plus 0. There is a number, but it's 0. And nobody writes plus 0. They just write y equals kx. So this is the direct variation. Even though there is a number, it's 0. But any other number that's not 0 is going to make it not a direct variation. It can be added, it can be, subtracted, but any number off to this side, automatically you can look at it and know it's not a direct variation. So with that said, let's go ahead and look at 10. And since going back to number 9, since it's not a direct variation, we don't need to say what the constant of variation is because it's just not a direct variation. Boom, that's done. Okay, you only state what the constant of variation is if it is a direct variation. Okay, moving on to 10. Is number 10 a direct variation? Is it of the form y equals kx? And what I see, like the last problem, is we have this -4 out on the side, right? So that means it's not going to be a direct variation. So this is not a direct variation. You can only have the y, the equal sign, the x, and the k just happens to be 1, right? But here, it makes it not a direct variation because it has that -4 out there. Okay? Let's go ahead and look at number 11. What do you notice about number 11? Is number 11 of the form y equals kx? Is y by itself? No, it's not. There's a 3 in front of the y. So you have to use your algebra skills to get y by itself. So you have 3y equals 6x. You got to get y by itself. This is 3 times y, so that means you're going to have to divide both sides of the equation by 3. 3 divided by 3 is 1. 1 times y is y. And 6 divided by 3 is 2x. So is this equation of the form y equals kx? The y is the same, the equals the x, and there you have your constant of variation. So yes, this is of the form. So yes, and our constant of variation is actually equal to 2. Okay, let's go ahead and look at the last 3 problems. Y equals 13x plus 0. Is that a direct variation? Well, if we write down the direct variation equation, y equals kx, the y is the same, the equals the same, there's the x, and there's a number in front of the x, which is okay. But what do we have right here? We have this plus 0 bit out to the side. And if it was any other number than 0, we would say this is automatically not a direct variation. But since it is plus 0, we can actually write this equation differently. We can write it as y equals 13x. We don't need to write the plus 0. It's really not needed. So is y equals 13x, these two things mean the same thing. Is that a direct variation? Is that of the same form? The y's there, the equals, the x, and there is our constant of variation. So yes, this is a direct variation just by looking at it, and our constant of variation, k, is equal to 13. Okay? Let's go ahead and look at problem number 13. Is problem 13 of the form y equals kx? Is y by itself? No, it is not. So we have to use our algebra skills and get y by itself. So what do we have? We have 4y equals 2x. We need to get y by itself. Right now it's being multiplied by 4, so we have to do the inverse operation of multiplication, which would be division. We have to divide both sides by 4. So we end up, 4 divided by 4 is 1. 1 times y is y. We end up with y equals 2/4 x. Now, whenever we're doing this, we want to try to put this into simplified form, lowest terms. Is there a number that goes into both 2 and 4? And the answer is yes. 2 goes into 2 one time, and 2 goes into 4 2 times. So we end up with y equals 1/2 x. Now, is that of the form y equals kx? And yes, it is. The y's, the equals, the x's. The constant of variation is right here. The constant of variation is 1/2. It's a fraction, and that's totally okay. So, yes, our k is equal to 1/2. Okay? Let's go with problem 14. Is this of the form y equals kx? Is y by itself? Well, right now, y is not by itself, so we have to do some algebra and get y by itself. So we're going to rewrite this problem here and get y by itself. So right now, it's being multiplied by 8. I need to divide everything by 8, so I'm going to divide this by 8 and divide that by 8. Everything gets divided by 8. 8 divided by 8 is 1. 1 times y is just y. I'm going to reduce this 4 eighths. 4 goes into both of those. 4 goes into 4 one time. 4 goes into 8 2 times. So I'm left with 1/2 x. Subtracted by, I'm going to reduce this. What goes into both of those? I'm going to say 4. 4 goes into 12 3 times. And 4 goes into 8 2 times, so it's subtracted by 3/2. Now, is this a direct variation? Is this of the form y equals kx? We have the y, we have the x, we have the equal sign, we have a number in front of the x, but we have this -3/2 over there, and that means that no, this is not a direct variation.